Hi there, welcome to the video. My name is Vinay and I'm a freelance software developer. In my previous video, I have explained how a software engineer can transit into AI development or LLM based development. In this video, I'm going to give you a quick demo of how a simple LLM based RAG application, retrieval, augmented and generation application, can be built with a simple plain Python code. So let's not wait too much, let's get started. So the project that we're going to build today is LLM based RAG application. You already have the data and your application will look into the data and answer to those questions that are related to that particular data. If you ask some other questions, it will just say, I don't know. That's what we're going to do. So a simple real world use case for this is, say for example, a company ABC has like huge data, like maybe billions of data, and if they want to build a chatbot. So what they can do is they can build an LLM based application where whenever their customers ask a particular question based on their data, the LLM will look into that data that they already have and respond to that users that this is the information that is there with me. If the customer asks something else out of the context of their business or out of the context of their data, it just responds like, you are asking me something which is not reachable to me. You may have to contact to my boss or however you're going to design. That's the use case, one of the use case. Similarly, there are so many use cases. That's a pretty common use case I mentioned. So let's get into our application where we're going to look into a movie fact data. And if customer asks about any of the questions that are related to those movie facts data that we have, it will respond. Otherwise, it will just say, no, I don't know. You may have to reach to my boss. Yeah, let's get started. Okay, I'm using PyCharm editor here. A community version is good enough. It's pretty powerful IDE for you guys. Or if you prefer any other IDE, it's up to you. Here I'm gonna go through these simple files that are required for our project. That is movie facts Q&A agent. If you see here, I have a couple of libraries which are required for us. PyAudio for any audio related libraries, it is a dependency. Speech recognition, we need it because we're gonna give input through audio. So whenever you talk, it will listen. For that, we need speech recognition, and that audio will be converted to text. NumPy, I'll explain during the course of the video why do we need that. And OpenAI is the LLM that we're gonna use in our application. And .env, we need it to load our environment files. Especially we're gonna get a OpenAI API key, and that key can be accessed through .env library. And PyTTXC, we need this because it's a text to speech. Usually OpenAI gives you the response in text, and that text has to be said in audio or audio format. So we're gonna use TTS means Python text to speech X3 library. So these are the important libraries that we need for this project. So next, the movie facts. This is the file I'm gonna use in our application. See here, I have listed 5 movies. Movie name one is Lion King, and I added some data to that. In Lion King, the roaring sounds are actually a mix of tiger and real lion. And for the movie name Frozen, the movie Frozen was inspired by the story The Snow Queen by Hans Christian Andersen. And another movie I have added the extraterrestrials, and also added some facts about Jurassic Park, and then another movie called Finding Nemo. So you can think this as your data. You could replace it with any of the movies that you want, or if you want to use it for actual use case, you can use our database also instead of a simple text file. As I said, this is just a tutorial purpose. It's not really a production grade application that we're gonna build, but instead we're gonna go through how we can access the OpenAI APIs to leverage our software engineering skills to build something related to LLM applications. So having said that, we need this OpenAI API key. I'm not gonna go and explain you how you get OpenAI API key. It is pretty straightforward. Go to Google and search how do you get OpenAI API key. You will get the key and place this key in your .env file. You're gonna copy this and create a file called .env. I'm not going to show that file because I have my key present there. So you're gonna place your OpenAI API key in the .env file. So yeah, these are the important files that you're gonna create in your application or project folder. Here I have created a project folder as RAG tutorial, So the important file that I'm gonna create now is movie fact AI agent. I'm gonna say movie fact RAG AI agent because we are demonstrating how to use RAG as well. I'm not going to create multiple files, or I'm not really going to follow some industry standards of developing an application. That's not the context of this video. I'm going to just show you how a simple Python script can leverage the OpenAI APIs to build something called LLM application or RAG application. So having said that, that's the file I'm going to create. Movie fact rag AI agent.py. So first thing first, create our virtual environment. Why do we need virtual environment? Virtual environment creates a virtual machine. It's not a virtual machine, but it creates a virtual environment for your project. So what all the dependencies or the libraries needed for that project will be there in that particular virtual environment only. So if you want to run the RAG tutorial application, you have to make sure you are in the environment of RAG tutorial. So how are we going to create? Simple, use the command python 3 or Python, whichever version. Python 3 is the preferred version. Python 3 -m venv and then name of your virtual environment. That is, I'm gonna name it as a venv as is. So let's wait. I think it has created a virtual environment for you. So once you have created, you have to activate it. How do you activate? Source venv bin activate. So now if you see, we are under the environment venv. So whatever you install in here will be in the venv environment. If you cannot access this outside of venv environment. So it's a pretty straightforward standard Python based application development standard. So now that I have shown you the requirements.txt, these are the libraries that we're gonna do. You can install in two ways. One, just to copy this and just do pip install and copy paste and enter, and it says it has installed it. The other way is if you have created a file like .txt which has all the requirements in it, the simple way is to run the entire file itself, that is pip install -r requirement.txt. So it's installing all the libraries at one go, so you don't have to install everything one by one. You don't have to go to PyAudio, speech recognition, NumPy, OpenAI, .env, all that one by one. Instead, we just listed everything in the requirement.txt file, and txt file is getting executed. That way, all the libraries will be installed in your virtual environment. So it may take couple of minutes. Yeah, it successfully installed. If you find any error during these installations, you might be missing some of the dependent libraries in your machine. If you just go Google it, I think you should be able to resolve it. Lucky me, I didn't get any of such errors, so I'm gonna go ahead with the project. Close this, go back to your Python file. Make sure you have placed your OpenAI API key in the .env sample .env file, where you're gonna place your OpenAI API key after this equal sign there in the .env file. Okay, so we have created a virtual environment. We have installed all our dependencies needed for this project. Let's dive into the actual coding. NumPy is a mathematical library which is pretty commonly used in the machine learning space as well as LLM based application development. It's you can think of it as a very fast mathematical based numerical library. NumPy, that is like numerical Python. So it helps in all the mathematical operations and it is very efficient. It's not like Python's list, which is pretty slow. It is very efficient way of. And so another is import. What we're gonna need is we need speech recognition. Speech recognition is too big of a word. I'm gonna just create an alias for that. That is SR. SR will, if I use SR, it's like speech recognition in my application. So now what else we need? We need text to speech. Whenever the LLM responds to us, we have to convert it to audio. So we're gonna use that library that we use, that is pytxt or something. pytxx3. Yes, this is the one. So what it will do, it will convert a text into audio. So after that, We also need OpenAI library. From OpenAI, import OpenAI. Yeah, this is their syntax. You have to use. OpenAI has so many libraries in it. We're gonna use only OpenAI client in it. So after that, what else we may have to read .env file and our environment variables. We need to import that as well from from .env import load.env. So .env is the library that we have in requirement.txt, and we have installed that. So in that library, we're gonna use load.env, which helps us in loading the environment files that is there in the .env files into our application. That is our Python file in here. So first thing first, we have imported everything successfully, and also we have to make sure we are loading all our environments. So this is how you're gonna load. If you just call this particular function, that is load.env, it will load all the environments variable in the .env file available in this file. Okay, so now how do we go to this env key? This is the key. So API key equal to OS. We don't imported OS. Let's see, get env. We didn't import the OS library. We're gonna just import that as well. Yeah, we have imported. Maybe okay. Yeah, we have imported. This is the API key, that is OpenAI. I'll just make it more clear for you. OpenAI API key. So this is the API key that is there in the .env file with this key. So it will give the value of this particular OpenAI API key that is present in the .env file. So now we have loaded OpenAI API key, and the next thing is we have to create an OpenAI client. What do you mean by OpenAI client? OpenAI client is like a library that we're gonna use to call any of the OpenAI APIs. OpenAI will respond to your queries if and only if you have provided the proper API key of yours. So we have loaded that API key to this variable. I'm gonna put it in here and save it. Okay, so we loaded all our imports, we loaded our environment file, we have created OpenAI client. Well and good. So before going to the actual logic, we're gonna create some utility functions. Utility function is say I mentioned about text to speech and speech to text. Whenever I input some audio to my microphone, to my MacBook, that audio will be converted into text. That's like a utility, right? It can be reused across our application. So what I can do is I'll just create a simple Python function which take the text and converts it to audio and send it back to the whoever the invoker is, or the whichever function called that speak function. So let's define that def, that is function speak. I'm gonna use the simple word speak. What it expects is it expects something called text, and it should be of type string. We'll just give some document to this. This method converts the given text to speech. Okay, now we'll create a variable which is again engine, we call it. It should be from Python text to speech library and init. So this function initializes the Python text to speech library for us. Whenever there's a method called, that is speak called, this particular engine gets initialized in the function. And now what we have to use already provided methods of Python text to speech. There is one simple method called say. So whatever the text you have passed, if you pass this text to the say, it will just say that in audio. As simple as that. There's no rocket science behind that. And once that is done, we have to use engine.run, and yeah, it just runs the engine and engine.stop once the speech is over. Typo there, engine.stop, and then I think we shouldn't use run, we have to use run and wait. That's the proper library there. It was run before, but I think recent changes have been updated it to run and wait. Okay, this is a simple method which takes the text and then reads the text, says it loud through your speaker as an audio. The text will be spoken as an audio. So that's the one utility that we're gonna use. The another utility we will be using is, so now this speak method will just say the text in the audio format. We also need another utility takes the audio input from the user. What do you mean by that is, you'll get to know when I implement that particular logic in here. Get voice input. What this function do is, it listens your microphone or your computer's microphone and observes that audio that you're gonna speak to that microphone, and that audio will be converted into text. That's what we need, because we have to input our LLM applications with a text. So we cannot input audio to LLM applications. We have to input text to our LLM application. So what we're gonna do, whenever user speaks to the microphone, that audio will be converted to text. So listens for user's voice and convert it to text. That's the function of this method. It do not take any of the input. To keep it simple, invoke this method and just convert the audio to text. So now I'm gonna use a variable recognizer, SR. You know, SR is our speech recognition library. I imported it as SR, so I'm gonna use that speech recognition, SR dot recognizer. So it will instantiate an object with SR dot microphone. So what we gonna listen, I'm assuming you're gonna listen to the microphone as well, until you have a different audio device. As of now, I have only microphone, which is my computer's microphone. I'm gonna use the same one. So with microphone as my source, I am that as R, so that came in inevitably. Recognizer dot what we're gonna use, adjust. There's a method, adjust for ambient noise. Yeah, this is the one we're gonna use. What it will do is it just avoid any noises in your microphone's audio and try to extract the exact words that you are speaking. That's as simple as that. And that's the source, that is your microphone source, and it will just give you audio ready to use. Recognizer dot listen. So it keeps listening to the microphone and give you an audio. So now we are having an audio. What we have to do is we have to take user text recognizer dot recognize Google. This is another method that they provide. If you don't know what these methods are, just go to the Google, ask what this method under speech recognition library. I think you should be able to find out what these methods does. And you have to input the audio that you fetched from your microphone, that is in here. Recognizer, recognize Google, and audio. So now let's print, instead of just going ahead, let's print what it has extracted. User said, I'll just print as user said. This one, what user has said, user text. Whatever it has extracted as text, we're gonna print it just for the debugging purposes, later stage, and then return that. Return user text. My typos, bear with me. Exception handling, there are high chances that you may have some exceptions there. Speech recognition dot unknown value error. If someone gets an unknown value, something is said during the video, It will just say, I will just print it for now. We're not gonna do anything. I'll just say, sorry, I don't understand you. I couldn't show you, LG couldn't understand you. That's it. Try again, maybe. Yeah. So we'll print it so that we will understand that speech recognizer has failed to extract data from the audio. So now we're gonna make use one of our library, which is speak. To speak the same sentence. See here, when speech recognizer fails to extract data, it will say it loud to the users, I couldn't understand you, try again. As simple as that. And it just call that and just return empty. There's nothing happening in here. And now this is unknown value error. There can be another error, that is request error, it seems. Yeah, I think request error. Yeah, as it. So could not request result from this Google speech recognition survey. There can be any reasons for this. Speech recognition is an open source library, but if for whatever reason, if it couldn't understand or couldn't convert the audio to text, just print that for your debugging and then you are good to go. I'll just say couldn't understand and just say return. This is just a debugging local. This is not the way you should debug when you are working. Make everything fast and quick. I'm just printing everything as is. You're gonna use loggings and everything when we're coding for the production ready application, but here I'm just printing everything in the console, so whenever something goes wrong, we'll immediately get to know that this is gone wrong. We're gonna go there and fix it. Well, we have created two important utility functions, speak and get voice input. Speak takes the text and converts it to audio. Voice input listens to the microphone and converts it into converts it into text. I also had a bug in here. I didn't have source before. Just make sure you will include source in here as well to the listen function inside get voice input function. Okay, along with these two functions, we will be needing another utility function that we're gonna use in our application, which is called create embeddings. You may have to give a text list to this, and this text will be converted into a different format, which is embedding format or a numerical format that LLMs can understand. That's how we're gonna convert our basic text into a LLM understandable format. So converts a list of text strings, I would say, into a list of vector embeddings. We're gonna use OpenAI's library for this as well. Usually different LLMs will be having their own implementation or their own APIs to create embeddings. As we are using OpenAI here, we're gonna use OpenAI's API for creating embeddings. Okay, so where is that? moviefacts.txt, we have this human readable text, right? So to make LLM understand this properly, we have to convert it into a different form called embeddings, and that embedding will be done in this method, and we're gonna call this method whenever we need that. First, we have to check if the text list present. So if not text list, just return an empty array, right? Since we are using NumPy, I don't know why I'm doing wrong with return. Yeah, return np dot array. Yeah, so np array is a NumPy array. Assume this as a simple Python list. just empty array in the format of NumPy. That's it. Okay, now we gonna use OpenAI clients. Have we defined OpenAI client before? I don't know. OpenAI client. Let's assume that we have defined this. Yeah, we have this OpenAI client dot embeddings dot create. Okay, so we are preparing this data for the OpenAI. What data, usually whatever the text we're going to pass to this text list will be converted into a different format that OpenAI can understand. So that's what we are doing in here. How OpenAI client has a method called embeddings, API called embeddings, and that API has a method called create, and that create function we gonna send input. At this time, what is the input? Text list. And which model is OpenAI provides a couple of embedding models, just like at this time OpenAI provides few embedding models. So we're gonna use those embedding model in here to create that text into OpenAI understandable format in a simple word. Yeah. So which model we're gonna use? Text embedding 3 small. That is one model that OpenAI provides. Text embedding 3 small, large, ADA, everything is there. Don't worry about much about this at this time. Try to understand we are converting the plain simple text into OpenAI understandable format text. So OpenAI embedding 3 small, that's the model we're going to use. And now it provides embeddings. How you extract the embeddings? Simple list comprehension. We'll say dt, that is our data, dot embeddings. I'll say embedding for dt in response that we fetched from the OpenAI's embedding API, and return that as a numpy.array. That is embeddings. Yeah. So now we just created an embedding utility. What it takes the text input and converts it into embedding that OpenAI can understand. You can assume that as a encoding, where your normal text is converted into different format that OpenAI can easily understand. That's what it does. And we used a model called text embedding 3 small, which is provided by OpenAI to convert any text into an embedding. Okay, that is it. And so now we have 3 utility functions that we're gonna reuse or use in our application. We might need one more such, which is last. Find most similar questions. Not questions, I would say find the most similar, maybe fact. Yeah, because we are dealing with movie facts. Yeah. So query embedding. And we're gonna take facts embedding. It expects 2 arguments, query embedding and facts embedding. So what it does, why do we need 2 arguments? Query embedding is, you can make this as a question embedding, whatever user asked for, that also has to be converted into an embedding. We're gonna do that later. Using this, we're gonna you call this function with the user input, and that gives the embedding. That embedding will be passed in here. And facts embedding is, we're gonna create embeddings for all these movie facts.txt files data. So it expects those 2, questions embedding and facts embedding. And then what it should do basically is finds the fact that is most similar. Okay. What do I mean by that? User will ask a question and that will be converted into LLM understandable embedding. And we have a list of embeddings. We're gonna match if user has asked relevant data or valid question, then we can respond. If not, we're gonna say, we don't know, we don't have that information. So to find that, we're gonna find similarity between the user question and the data that we already have. So that's what this particular method gonna do. So if facts embedding dot size equal to 0. Say if facts embedding is not there, maybe assuming that movie facts is not at all there, so we just say return -1. There is nothing to send it back. Otherwise, we're gonna find the similarities. How? We're gonna use NumPy here. Why do we need NumPy? NumPy is so powerful mathematical library. We're gonna use this np.dot. If you know the matrix and matrix multiplication, dot is a dot product. It's in simple words, in a two-dimensional space, 2 cross 3 is 6, so that's a dot product. I know, in a simple vector. And if you want to go with the matrix multiplication, 2 cross 2 matrix multiplied by another 2 cross 2 matrix will give some product. So all kind of dot product will be performed using the dot method of the NumPy. Just go through the Google and understand what dot method does for you. And facts embedding, comma, what we gonna try to have a dot, that is with a question embedding, right? User has a question and we are going to create a dot product of that to find the similarities. So basically every facts list, to give you an example, if you go in here, this is one fact, this is one movie's fact, this is another movie's fact, this is another movie's fact, this is another. So we have 5 movies fact and we have one question. What we have to do is we have to find the similarity, which particular question user is trying to get the answer from. Easy asking about the movie called Lion King, or easy asking about the movie called Frozen, or extraterrestrials, all that. So based on that, it creates a dot product and gives you a similarity. If the NumPy feels that this is what user is asking, so for each of the embedding, it will give you a similarity score. Most similar index. Yeah, we need index because see here we have 5 lines. We need the index of the most similar fact that user trying to read. If user is asking for the Jurassic Park movie question, we have to return the 0, 1, 2, 3, the index 3, isn't it? So that's the index of it. How do we get that? We're gonna use another NumPy library here, numpy.argmax. I think here, argmax. What it basically does is the same. It will give you the index of the highest number of the array, in simple words. Yeah. Argmax similarities. So similarities has the dot product of each of the facts along with the user question, and in each of that similarities we will get the maximum similar index or most similar index, and that index will be returned back. Return most similar index. So basically what it does, I don't want to make it too complicated, it just tries to match the user question with the available data with us. If it finds something is matching with one of our data, it gives the index of that line, and that's what it does. Nothing so rocket science about it. Just get the user question embedding, match it with the facts embedding that we already have, send it back. This is what the most similar I can find, and I'm returning it back. That's it. Yeah, this is not the only way to find the similarities. There are multiple mathematical ways to find the similarities. This is the simplest way of finding the similarities. I'm saying there are cosine similarities and all other different sort of similarities that production grid application uses. But for now, for demonstration purpose, this is enough for us to understand which is what we are trying to do. That is, we are trying to do a match between the user question embedding and data that we already have. So that will do for us. Okay, now that we have all the libraries ready, we are ready to get into the actual code of our LLM. So that we have all 4 required utilities, it's the time to start our actual functionality. That is reading the embeddings for the file, getting the input from the user, sending the request to the LLM with the context of our movie facts and get the response, and then convert the text response to the audio. First thing first, we're gonna get the file, that is our moviefacts.txt file, moviefacts.txt. And now we have to get the facts checked. What I mean is we have to get our movie facts. So how do we get the movie facts? We have to read that movie facts file. We're gonna do that with the help of a function, that is load movie facts, and that should expect a file path in there. Okay, so we have to write this function now. Def movie load movie facts. Here is the file path, and then what we have to do is we have to give a docstring for this as well. Loads movie fact. For each line, that's what it specifically does. Okay, if first of all we have to check whether the file is properly present or not. So we have to check whether the file exists or not and properly present or not in the path that is provided here in the file path. So we can do that with the OS library os.path.exist. So what it just checks whether this exists, and if it exists, if not exist, just return empty list. You know what, we can just call our utility, that is speak. I cannot find the file provided. Yeah, that would do. So now, assuming that everything is good, the file exists, and there's no need to say that file do not present, let's start reading the file with open. Open is the function to use to read the files in Python. File path, how do we open that file in read mode? And we may have to, just to safer side, we'll mention the encodings. Encodings is equal to UTF-8, yeah, UTF-8, yeah. So as F, so, and then now that it's the time to get the facts from the file, facts is equal to, we'll just get the facts in every line as a separate fact. Okay, movie number 1 is a separate fact, movie number 2 is a separate fact, all that. Now for line in f.readlines, readlines method, it reads the entire file line by line. We're gonna use list comprehension. We need line dot strip, so it gives the proper line data by stripping any extra in there, in case if it exists. If the line exists, it's fine, otherwise we don't have to strip it, otherwise it just throws an error. So we'll add this if condition there, and that's it, and just return the facts. That's what it does, it just reads the file and return the facts line by line. So we have the file, we have loaded the movie facts of every line, and now it's the time for creating embeddings for that movie facts that we loaded, right? Where is it here? If not movie facts, if for whatever reason there are no movie facts after loading the movie facts method, let's again speak no facts found for file. Okay, we will use f string. So this is the file path. Mention that. I don't know how it will says it out loud. I'll just say movie facts. I hope it just say movie facts.txt. It's like no facts found for the file movie facts.txt. Okay, and then if just exit the control. Let's create embeddings now. Embeddings. We already have a create embedding method which expects a list of functions, list of text strings. We have our movie facts loaded here. We'll just pass that to create embedding method, and that gives us the facts embedding. So we have created a LLM readable embedding for all of our data locally. So it has all the embeddings now. So now it's where our actual code starts. So let's say that out loud. Speak. That's the method we have created. Speak. Hey, I loaded earlier movie facts. Shoot me the questions. Question. So now that everything is good, we are thinking that it's all good, everything is working. There are movie facts loaded. What we did is we just created a fact embeddings or movie embeddings you can call. After everything is fine, we just called our speak method. Hey, I loaded all your movie facts, shoot me your question. So it is ready to answer your question now. Okay, now what to do? Now we have next input should be from the user. The agent said that I am ready to answer your question. User has to give the audio input. How we gonna do? We're gonna use this trick of while loop true. So it's going to go infinite loop, isn't it? If we say while true, that means there is no endpoint in there. How user can input the audio is through his microphone. So we'll just take the user question using our own method that we created, get voice input. So what it does is if you go in there, it listens to your microphone and converts that audio into user text and returns it back, and that's it. So we got the user question already. So user question is ready. We'll just check whether user has asked the question or not. If user has not asked the question, just keep looping, isn't it? We have to wait until user asks the question. Okay, for now what I'll do is we need an exit condition to stop this, otherwise it will be keep on looping, isn't it? So what I'll do is when user say goodbye, we can definitely use LLM for this to identify the user intent, whether is he trying to say goodbye or he wants to have a question, but I don't want to go make it too complicated. I'll just look for the word goodbye in user text. If it is there, gonna say okay, lower is just lowers down all the letters in the user's question, or maybe we'll do it in other way. If user question dot lower has goodbye, we'll end the loop in here. Speak. I hope I helped you today. We'll talk to you later. Talk to you later. Goodbye for now. So this will be spoken by your agent. So what I'm doing here is just starting a infinite while loop, while true, trying to get the user input using our method get voice input. If there is no user question, user has not asked any question, it just keeps looping. When user question is there, or is there any user input is there, and if it has something called goodbye in it, I'm just assuming it's like a hard coding or rule-based method of exiting the loop. So if the goodbye is present in the user question, your agent will speak, I hope I helped you today, we'll talk to you later, goodbye for now. So now the actual part, query embedding. Create embedding with user question. So whatever user has asked, we're gonna create embedding just the similar way how we created embeddings for our facts. We're gonna create embedding for the user question, so LLM can understand. The query embedding or question embedding or whatever you call, I'll just make it as QUESTION, that is question embedding. And now relevant fact. What does this mean is we have to identify what is the relevance of the user question with our data. We have to find that. How do we do that? We have created a find most similar fact which expects query embedding and fact embedding, isn't it? What it expects question embedding and then facts embedding. First we have to send the user question embedding and then comma facts embedding that we have for our data. Create embedding, where it went. Yeah, question embedding, what is the error? Shadows the question. Okay, I have used the variable question embedding, so it's better not to use the same method in here. I'll just use quest embedding or question embedding. Yeah, so it should clear that warning. Yeah, find most similar fact, send the user questions embedding, and then the embeddings that we have, it gives you a similarity score, or it gives the relevant fact. If relevant fact is equal to -1, if you remember, if you go to that method, we are returning -1 if there is no similarity there. See here, facts embedding dot size is 0, so if it is -1, just speak again, no facts to search. Or the question is out of reach for my knowledge. Why not? Yeah. So far we haven't touched any of the LLM based application apart from embedding creation, right? This is what it is. AI development, AI engineering is all about, it's like 90% is software engineering, only 5 to 10% is LLM based engineering. Okay, where are we now? Relevant fact. If there is no relevant fact, we gonna say that no facts to search and all that. Okay, relevant fact, movie facts. This is relevant fact index, isn't it? Yeah, it just returns the index. If the index is -1, that means there is no index present. Yeah, that's true. And now actual relevant fact. Movie facts, we have facts and relevant fact index. Which relevant fact is, it gives this find most similar index, gives us the index. So this movie facts has a list of all the movies facts. So what index it is trying to give? This is 0 index, is first index, is second index, is third index, is fourth index. So we are going to get the relevant fact from the movie database that we have, that is our moviefacts.txt. Now comes the prompt. We have to send a prompt to our LLM so that it should identify whether the user is asking the relevant question or not. What the prompt I'll generate is, I'm telling LLM that you are a helpful assistant that provides accurate information based on the provided facts. It is getting too long. Based on the provided facts, right? Use the following context. Okay. Use the following context to answer the question the context we're going to provide that in the prompt itself. Okay, if the context is not relevant or irrelevant, relevant, or if you don't know, or if you don't have enough information, say that you don't know. Isn't it? This is what prompt engineering is. You have to build your prompt in a very sophisticated way that LLM can clearly understand step by step what you are trying to ask, what it has to do, and how it should give you the response. This is what we call the prompt engineering. Okay, now that we mentioned we're going to provide context, we'll provide context as relevant fact. I'll just put it in a double quote so it is evident for the LLM to understand, and the user question that he has asked. What user has asked? User question, where we have that user question is here. We got it from the voice input. We're sending that this is the user question, this is the relevant fact. We are thinking that this is the relevant fact. How do we identify the relevant fact? Through our embedding matching. If it feels this is the relevant data for this question, it gives you the response. Okay, now that we created a prompt, let's call our LLM API. OpenAI client dot response is OpenAI method, OpenAI API that helps to respond back this is the way you want. You have to call that API to get the response from the OpenAI. We're going to use a model. At this time, we're going to use model GPT 4.0. Yeah, 4.0, not 40, 4.0, and then mini. This is pretty powerful model. For these kind of use cases, we don't really need GPT 4.0 mini. Maybe a 3 turbo would do well, but it's okay. We can just test it for our requirement. Input is our prompt. You have to call this API in this way only. OpenAI client responses create, model is this model that we're gonna use, and input is the prompt that we have just created. You're a helpful assistant that provides accurate information based on the provided facts. Use the following context to answer the question. If the context is not relevant, or if you don't know, or if you don't know, or if you don't have enough information, say that you don't know. So the context is the relevant fact that we got from our similarity matching, and the question that user is asking that we got from the microphone audio to text. So now it's the time to see LLM response. What should be LLM response? I think response, it gives output. Yeah, a list of output. I'm gonna take first output from the list and then take the context of 0 and then the text. Yeah, so we'll use this and then speak whatever our LLM has responded. All good. This is what it is: retrieval, augmentation, and generation. I'll comment where the retrieval is happening, where the augmentation is happening, and where the generation is happening. RESP. Just use the RESP here just to avoid any naming conflicts without a scope. Okay, where the retrieval happening in this code? Retrieval is here. We are loading our data, that is movie facts data. Retrieval. Yeah, and then where the augmentation is happening, we created this. The LLM will look into the context and take the questions and augment your answer. It do not just give you the answer as is present in the data here, but it augments it, enhances it. So that where it's happening in here in your OpenAI call, that is augmentation. Augmentation, is it right? TION, yeah. And where the generation is happening, you can assume this as a generation. It's happening from the prompt itself. Yeah, augment that and then generate it. So I think I never ran this script before. Let's see if it works. If it works, well and good. As I said, this is not a production ready code. It all looks clumsy. The code shouldn't be like this in the production code. For now, for this video demonstration, this is way more better than the normal other videos where they explain LLM. This has actual implementation, actual utilities that you can use, reuse, and then how you're calling the LLM application and everything. From there you can learn further and come up with your own applications based on your requirements. Okay, time to run this. Let's run this.
Hey, I loaded all your movie facts. Shoot me your question.
Did you hear that? Okay, there is something wrong in this. The numpy dot value error, not aligned. Let's see what's happening in here. Okay, I have to debug this. Let's see how we are calling this method. Find most similar fact. Okay, in here, find most similar fact, create embeddings. We are creating embedding for user question user. Okay, I think there is something wrong in here. Create embedding. If you go in here, text list. Okay, it should take the list. User question is basically a single line. We have to send that in the list. So we'll just put it in the list, and it returns the list as well, I guess. Yeah, it returns the numpy list. And if you go to in here, we have just fetched the first element from the fact embedding, not from the fact embeddings. Sorry, where it went, the user embeddings. Yeah, so we'll fetch the first element because we just we are allowing just one question from the user at a time. So user question embedding, find most similar fact. Question embedding is ready. Single embedding, earlier we were sending the list, so now a single list is a single sentence is going there. Let's try to run this now. Okay.
Hey, I loaded all your movie facts. Shoot me your question.
It sounds so weird, isn't it? Like the voice should be good, should have been.
Sorry, I couldn't understand you. Try again.
Okay. Tell me about the movie Frozen. Again, another. Did you mean content? Something is wrong here. LLM response, let's see.
Hey, I loaded all your movie facts. Shoot me your question.
I love real dinosaurs of Jurassic Park. Okay, it gave those in here. Response. Debug it, evaluate. Okay, there is an attribute error. That's the error we are getting. Context is not there. Let's see what is there in the output. Output of 0. It should be content. Why did I mention context? Content in the 0, and then if we fetch text in here, yeah, okay, it responded. I don't know. Let's see. Whatever. At least we are not seeing the error. It's not context, guys. It is content. I'm gonna replace that in here. Let's stop it. Try to run this again. So the question I'm gonna ask is, see, I have added a Jurassic Park movie fact. The T-Rex from Jurassic Park was not dinosaur, but an animatronic puppet. So what I'm saying is, I'm asking, I love the real dinosaurs of Jurassic Park movie. So I don't want our LLM application to respond whatever it wants. It should respond based on this. Even if I try to influence it that this is a real dinosaur, it should respond me back properly as per the context. The real dinosaur is not the case. Let's see. In run mode.
Hey, I loaded all your movie facts. Shoot me your question.
I love the real dinosaur of Jurassic Park movie.
I don't know. The context states that the T-Rex in Jurassic Park was an animatronic puppet, but it does not provide information about any real dinosaurs.
Nice.
Sorry, I couldn't understand you. Try again.
Frozen movie was not inspired by the Snow Queen story.
The statement Frozen movie was not inspired by the Snow Queen story is incorrect, as the context indicates that the movie Frozen was indeed inspired by the story The Snow Queen by Hans Christian Andersen.
Within the context of our data, it start responding, and it start responding in a very augmented way, not just the way that it is there in the data. And it responded with accurate data, not hallucinating with any other data that it finds online. So that's the power of retrieval augmented generation. So the use case is, if a company or you have a huge data sitting in your database or somewhere else, what you can do is you can just use that data and ask LLM to answer based on the context that you have provided using a prompt. So that is what retrieval augmented generation is. And this is what AI agent development is. As I said earlier, this is not an application that you can use in the production, but you can definitely start from here and then bring it further based on your learnings. So Thank you. Hey guys, well, that was it for today's video where I demonstrated simple RAG application using OpenAI APIs. That's the first step. It's not really a production grade application that I demonstrated here, but you can definitely build on top of it and use some of the industry standard practices to bring a production grade application. Definitely it will help you to understand how easy it is and how easy it is to build a LLM based application and how you can use your software engineering skills. As I said, software engineering is most of it. It's not about LLM based application. It's only 5 to 10% of your application, but software engineering is nearly 90% of it. So as I said, software engineers can easily transition into AI development, and from here they can even go into deeper concepts like machine learning and neural networks. That's up to them, but at least an application can be easily built by a software engineer. And as I said, I'm a freelance software engineer. If you're looking for something similar, or if you're looking for a production grade applications for your use cases, I have given the link below to my Calendly link. You can book a consultation call, which is free, and you can reach out to me on the email that is there in my website as well. Stay tuned, hit the subscribe button, keep supporting us. We'll come up with new videos going forward. Thank you.